All right, so we had gone over again our definition of a limit. We've said you've got to pay very close attention to what some of that notation is, because if you see a little negative sign on the right-hand side of a number, because that's not where negatives typically belong, what does that mean? The limit coming from the left. So as I look at the function, as I come towards 6 from the left, we're approaching 0. Whereas this is the limit as we approach 6 from the right. And on that guy, I'm coming close to 4. So because those two do not agree, the limit does not exist. So what we were talking about for this whole warm-up, whether it was with numbers or with letters, is the fact that when you're looking at a graph, a limit is what you are approaching. The thing of the matter is, while in life we have a lot of really weird graphs, because life's not like this nice, predictable, constant function, we have changes and everything like that, at least where we are right now, our functions, when we have equations, typically don't look like this. Do you understand what I'm talking about? Your functions are not like this crazy piecewise with all of this nutty stuff involved. So what we do is we have to have a way to figure out limits from just functions without a graph. And it's really not a terrible idea. It's actually quite straightforward. If I were to say I have the function y equals 5. So that is a constant value. If I have y equals 5, I can graph that. And it doesn't matter where along the line I'm at. What is the limit of f of x as I approach 0? What's the height going to? 5. What's the limit as I approach, let's go to 8? Negative 8. Pretty nice and straightforward, right? Doesn't matter where you're coming, because your function is constant, the limit is always the same thing. If I were to do something else, and let's say 2x plus 1, and graph that guy, what is the limit as x approaches 0? Not 0. It's just 1. And if I were to take the limit as x approached 2, what is 2 times 2? Plus 1? 5. It's very predictable, right? Basically, what we were talking about last class is two main ideas. We said that if we were talking about the limit of a constant, it always is that constant, okay? And that's where we're talking like y equals 5, because there's no variable involved. It's always going to be that number. Whereas if you have a function with variables in, basically it's just plug that value in. And so we said, hey, that's really nice. If there's an x, plug your number in for x, see what you get. If there's no x, it is just that number. Can I get you to close the door for me, please? Thank you. And so that's what we were doing right down here. We can think about calculating the limit as just basically substitution. And that's kind of where we left off. And then we got to this, and you guys started going, oh, dear Lord, that looks nasty. It looks nasty, but it's no different than what we've been talking about. This basically says if you have a limit where you have like functions in both the numerator and the denominator, you really can, again, just plug your value in. Plug it into the top, plug it in the bottom, see what you get. The only thing you've got to be careful about is that if you plug that number in and you get 0 in the denominator, what happens when we divide by 0? Undefined. And that means I have either a hole or an asymptote in my graph right there. So basically, if you plug it in and you get a 0 for your denominator, try to see if you can simplify before you do your substitution, before you take the limit. Okay? So what I want you guys to do is I want you to go ahead and write down for me number 9 and 10. And again, for those of you who came in late, I think some of you guys are missing quizzes. We will be doing that at the end of this block. Okay? When everybody else is working on their homework. Is the traffic getting any better? No? Still nasty. JD come in? Yes, JD came in. Alex came in. So we're just missing 2. All right, so get those guys written down. And you'll see that even though that stuff that I gave you right above looked kind of scary, it's not. It is exactly what we have been doing. No changes at all. That's what we started off going over. We didn't really get through too much. We did a really big review before their quiz. Okay? All right. So watch how simple this is. Again, you start by looking at this number and you plug it in. So 1 cubed is times 5. So I've got 5 minus 1 plus 2. What is that? 6. Yes, it's 6. I plug 1 in. What is 3 times 1? Plus 4. That's it. The limit of a function at a value, the easiest way to do that is literally just plug that value in. See what you get. As long as that denominator is not 0, you're okay. Now, guess what's going to happen on number 10? It's going to cancel. Because if I put 3 in here, what's 3 squared? 9. Minus 9? 0. So that means I can't actually do this through just standard substitution. So I need a factor. What is the top factor to be? X minus 3, x plus 2. What is the denominator? X minus 3x plus 3. So what happens here is I am going to just simplify. And if I were to look at my graph, what would happen here? A hole. That's going to be a hole. What's going to happen with this piece? That would be an asymptote. Just a little bit of a review of what we've talked about. So that means that this guy is going to be the same thing as the limit as x goes to 3 of x plus 2 over x plus 3. Now I can try just by plugging it in, see what we get. What is 3 plus 2? 5. 3 plus 3? Done. How is that? Pretty nice? Now, if I had simplified it and I asked you to find the limit as x goes to negative 3, I still would have had a 0 in the denominator. We would have said does not exist. That's one of your infinite discontinuities. So you wouldn't have been able to do that. So what I'd like you guys to do is go ahead and give 11, 12, 13, and 14 a shot. All on your own. Okay, so here are our answers. Take a look at number 12. How does 12 factor? This is a grouping problem. GCF here. X squared, take it out. X minus 2, GCF here 1. Oh dear Lord. It would work, yes, ish, but it's annoying. All right. Take a look at those. Let me know if you've got questions. I absolutely, like when I started doing this stuff, there was no turning back. It would be math teaching for me. It was like, I am going to do this. This is amazing. Everything comes together. I'm a nerd. It's okay. But I love this because it's like literally everything comes together here. Oh my gosh, seriously. Yes, ma'am. Could I do 12? All right. So let me work it on the back. What was the equation? X cubed minus 2. Okay, guys. So, okay, so I'm assuming that the problem is in the factoring. So you probably were able to get the denominator pretty well. So that was going to be x plus 4, x minus 2. When we're looking at the numerator here, 4 terms we factor by grouping. So we say, what is the GCF for those 2 terms? X squared. And when I take x squared out of those 2 terms, I'm left with x minus 2. What's the GCF here? Well, the GCF is just 1, because, yeah, there's nothing I can take out. And now that I have the x minus 2's in both, that's okay. Sometimes you just need it slowed down. So now that's where I get the x squared plus 1, and then we take out the x minus 2. Okay? Alrighty. So other than a little hiccup with factoring, how do you think you're doing with this? Pretty good? Okay, there's one last little thing about limits that we have to talk about. Infinite limits. Don't give me that look. Don't give me that look. All right, so let's think about this using substitution, just like we've been doing before. Go ahead and write down for me 15 through 17. I don't always give you guys enough time to write stuff. Okay, so if we think about finding limits as doing substitution, where do I substitute in the infinity? Nowhere. So what's the limit of 5 as x goes to infinity? 5, because that is always going to be 5. If I'm looking at this one, you can think of it still as substitution, so that's going to be 1 over infinity. And let me just take this the easy route. If I go to my y equals and do 1 over x, I can go to my table. What happens as my x's get bigger and bigger and bigger? It gets smaller and smaller and smaller. If I look at the graph, what do I say x is doing as I go out to the right? It gets closer to 0. What do we call this line right here? That's the asymptote. So as x goes to infinity, my limit here goes to 0. So what would happen if instead of having a 1 up on top, if I put a 4 there? It's going to be the same thing. It might not get to 0 quite as quick, but it definitely goes there and it's almost as fast. So this guy is also 0. So what you need to understand is if we're taking the limit of something and it is a fraction with a variable in the denominator and you're going to infinity or negative infinity, it doesn't matter. This guy is always going to go to 0. And that's the main idea behind finding infinite limits. So go ahead and write down number 18 for me, please. So these guys are a little bit more complicated. I could factor this, but I don't think it's really going to do me any good. So we need to figure out what can I do instead. What I can do instead is look at each of those little pieces and say, okay, can I make it so that I know I'm going to have certain things that go to 0? And this is the way we do it. You look at the highest power in the denominator. So what is the highest power in the denominator? Cubed. And what we're going to do is we're going to divide everything through by x cubed. Okay? So this becomes the limit as x goes to infinity of 4x squared over x cubed. 4 over x. X over x cubed. 1 over x squared. 2x cubed over x cubed. 2. And then I'm going to have 8 over x cubed. And we can use that idea that we just saw from up above, the fact that when we have a fraction where the denominator has a variable in it and the top doesn't, then all we need to do is say, guess what this is going to go to? 0. What's this going to go to? 0. What's this going to go to? 0. So that leaves me with 0 over 2, which is what? 0. So the limit as x goes to infinity for this guy is going to be 0. If I looked at the original equation, let me make that go away. If I looked at that original equation, what could you tell me about a horizontal asymptote? The degree of the bottom is bigger than the degree of the top. What does that mean? Y equals 0 is your horizontal asymptote. Getting someplace? Let's try the next one. Go ahead and write down number 19. Going to handle this the exact same way. What is the highest power in the denominator? 1. So I'm going to divide each piece through by x to the first power. So that means I can think of this instead as the limit as x goes to infinity of, what's 3x over x? 3 plus 5 over x. 6x over x? 6, and oops, that's supposed to be minus 8 over x. So since x is going to infinity, what does this go to? 0. What does this go to? So I'm left with 3/6, which is 1/2. And if we kind of take a step back, the degree of the top is the same as the degree of the bottom. It's just the coefficients. So y is 1/2. Well, considering the fact that you're going to have infinite shortcuts in a second, yes.
Always?
Yes. I will show you the shortcuts in a second, but there is one more little thing that you've got to be careful about. Yes, it is. It's just not picking it up. Okay. I don't know. I'm special. All right. So as I go to infinity, this is again talking about end behavior. What is the highest power on x? 1. And is that positive or negative? So what does that do on the right? Goes to the up or down? Up. What is it going to do on the left? Same or opposite? Opposite. So on the left it goes down. And if I'm talking about what am I going to be as I go to negative infinity, what is my graph going to? Negative infinity. Yes, sir. Because I've got, basically I'm left with x plus 1 over 2. So that's x over 2 plus 1 over 2, or 1/2 plus 1/2. Yes, ma'am?
So could you just use that same chart that you memorized?
Exactly. It is the exact same thing. And we can actually make it one step easier, believe it or not. Because all I really care about here, did that 1 do anything for me? Did that really affect my graph? Did the 5, did this affect my graph? The only thing that really affected was the highest power in the top and the highest power in the bottom. That's all we really care about. Even when we're talking about end behavior, we are just looking at the highest power on x. So what I can do for this problem here is I can just look at the highest powers on x. So I'm just going to look at this and this. Because when I divide through by my highest power on x in the bottom, everything else pretty much goes away or doesn't really affect us. So what I'm looking for is the negative 3x to the 4th over 2x. And so this is going to be the same thing as the limit as x goes to negative infinity of just that stuff. What does that simplify to? Negative 3/2 x to the 3rd. Because I don't really care about anything else when I'm talking about end behavior. It's only that leading coefficient and the highest power on x. So if I were to think about the graph on this one, on the right-hand side, what would it do? It goes down because of that negative. The left-hand side, would it be the same or opposite? Opposite. It would go up. So the limit as x goes to negative infinity is going to be what? Infinity. Does that make sense? Okay. And then one more problem, and this guy again, we don't really need to go too crazy into this. All I care about is the highest power up here. So that means I'm going to ignore that. All I care about is the highest power here. So I'm going to ignore that. So I can think about this as the limit as x goes to negative infinity of 2x squared over, what is the square root of x to the 4th? X squared. So what is this one going to be equal to? Not 0. Degree of the top and the degree of the bottom are the same? 2. It's the coefficients, because that would simplify to just 2. So, some shortcuts for our infinity rules. These shortcuts are basically your horizontal asymptotes. And if you guys are talking to some of the other pre-calc folks from the other teachers, they were like a day behind, so they didn't get to do graphing rationals. So they're actually learning all new stuff here. So you guys just makes it a little bit easier if you get that chance. So the degree of the top is the degree of the bottom. The horizontal asymptote is the limit, whether you're going to positive infinity or negative infinity. It's just the way it's going to be. If the degree of the top is less than the degree of the bottom, then your horizontal asymptote is the same thing as the limit. It's 0. So the only ones you really need to think about, just like we did on the regular graphs, is if the top is actually bigger than the bottom when we're talking about degrees. Then the limit is going to be either infinity or negative infinity, and that's just using your end behavior. That's it. Is that fairly straightforward-ish, maybe? So again, all of these rules just correspond to your horizontal asymptote rules. And the only one you got to really kind of think about is when the top is bigger than the bottom. But as we saw on the problems up here, we really can just ignore everything but the highest power in the top and the bottom. And go from there and just simplify it and see what it gives. Okay? So if I said we're going through problem number 27, here's a really hard math question. How many problems do we have left? 4! Good job, Elise. So smart. Something. Shut up, Augsburger. All right, so we've got a couple problems. Here are 2 of them. You even have the notes right above it if you didn't finish copying them down. So what I want you guys to do is I want you to do 24 and 25, finding for me the limit. That's a positive infinity. The other one's a positive infinity as well. Okay? Go for it. Using everything we've done. So this is what your answer should have been. Questions on those? No. And as you can see here, I just looked at the highest power on x. Because really, when we're talking about going to infinity, it's just, what is that going to simplify to? What is your end behavior looking like? All right, so here are your last 2 that we're going to work together. You guys actually are going to work them on your own, and then what we're going to do is I'm going to give you your homework. And then my folks that need to make up their quizzes, they're going to take their quizzes. Your brain hurts? Always. All right, there are your answers. Don't let the square root in the denominator freak you out. Just simplify it. So are you guys okay with my substitution and infinite limits? No, not really. All right, so what I want you guys to do is pay close attention to the worksheet that I just gave you, because they're all over the place. Some of these problems, mostly problems 1 through 20, are all going to be limits as you approach a number. Okay? Whereas on the back, starting with number 21, we're going to be going to infinity. But you've got to pay attention whether it's infinity or negative infinity. Okay? So this is your homework. Every single one of you should finish this before we leave class today. So with that being said, I am going to ask you guys to do me a favor. Let's just stop this.